All right, today we're going to talk about another type of transformation. And again, remember, we're talking about something that can change the position and sometimes the size and orientation of a shape. We are going to talk about rotations today. When you rotate something, we're going to deal, you can rotate it in any number of degrees, but we are going to deal with primarily 90, 180, and 270 degrees. And when we're rotating that, you can see in this figure here, how when you are rotating every single point at 90 degrees, when it says this, we need to remember that we are talking about it as counterclockwise around the origin for here. So this is 90 degrees counterclockwise, 180 degrees counterclockwise, and 270 degrees counterclockwise. We could also express that as, this would be, first one would be 270 degrees clockwise, and then the last one would be 90 degrees clockwise, just the opposite of the counterclockwise. But notice what happens with the ordered pairs. So in the first one, 90 degrees counterclockwise, it's the opposite of your y value and then your x value. When you are talking about the 180 degrees, you just do the opposite of both ordered pairs. And then for 270 degrees counterclockwise, you do the y value first and then the opposite of the x value. So an example here, if we are doing 270 degrees counterclockwise, I like to remind myself every time that we are talking about, the original ordered pair x comma y, and then how does that change? We're going to make those ordered pairs y comma negative x. So we look at our original ordered pairs of 2, 2, 3, 4, and 4, 1. And how does that change to our new ordered pairs? My y values go first, and this should be a prime, b prime, and c prime. My y values go first, and then I'm going to take the opposite of my x values. And this would be my new triangle. And this is as I am going 270 degrees around the origin. For this next one, rotate 90 degrees clockwise. This was actually be the same thing as 270 degrees counterclockwise. So we're going to change this one to 90 degrees counterclockwise. Make sure you add that. And then remember, when we're doing counterclockwise, that means we're going to go opposite of b comma a. So this is going to change to the opposite of our y value, comma x. So first off, write our original ordered pairs of -4, -3, -6, -2, -4, -1. And then when I change those to my a prime, b prime, and c prime, the opposite of my y value first would be 3, and then 2, and then 1. Then I keep my x values in my y spot. So then I would be at 3, -4, 2, -6, and 1, -4. And this is 90 degrees, again, if I'm doing it counterclockwise. So this next one has two things happening to it. So first off, we're going to take our original ordered pairs of R and S, which is 1, -3, and 2, -6. And then we want to do the first thing to it, which is a rotation of 180 degrees. So that means we're going to take our X, Y, and we are going to take the opposite of both. So -1, 3, and -2, 6. And then for my double prime, I'm going to be taking the reflection in the y-axis. When I do the reflection in the y-axis, I take the ordered pairs I was just at, I take the opposite of y, and opposite of x, and then keep my y. One, 3, and 2, 6. That's how I would do both of those. Next thing I'm looking at is rotational symmetry. When a figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. So when I'm looking at this figure here, in the center here, I have those 5 points around there. This star is, when I rotate it on those 5 points, it's around the center, it's going to be the same. And because it's those 5, it's going to be 360 divided by 5, which gives me my 72 degrees. This is not the same on that. So if I rotate it 180 degrees, if I rotate it 90, it's going to be this figure on the right, which is not the same. If I rotate it 180 degrees, it's going to be the next figure, which is upside down. So that's not the same. So then this one would have no rotational symmetry. So looking at this one, take a second here to decide if these 3 figures have rotational symmetry. And this first one would be yes, 120 degrees, 360 divided by 3. Give me 120 degrees on that center point. The middle one would be no. And then the last one would be yes at 180 degrees. And that will conclude our notes for 4.3.